Hi, my name is Sarah Lunn, and this is my assessment task 1 for EDMA414, and my focus area is linear relationships. Mathematics is often characterized as negative. It's characterized negatively by both students and the wider community. Research currently suggests that by the age of 8, some students are already referring to themselves as not being a maths type of person and experiencing anger, sadness, hatred, and boredom when faced with maths. Many of these students are asking, what's the point of maths? Contrary to the perspectives of these frustrated students, mathematics appears continually in our lives. We draw upon these understandings and skills when navigating, determining likelihood, measuring, estimating, or when listening to the statistics offered by politicians, salespeople, or advertisers. The importance of having strong numeracy skills is highlighted by its position as a general capability in the Australian curriculum. By including numeracy across the curriculum, ACARA intends to ensure Australian students develop this knowledge, skills, behaviours, and dispositions that they need to use mathematics in a wide range of situations. Having sound numeracy allows us to participate in daily life and make sense of our world. Algebra is a form of mathematics which utilizes both letters and symbols to represent unknowns or variables in an effort to illustrate mathematical relationships between quantities, formula, and equations. It is a tool which is used to express generalized mathematical rules and a tool to use when finding solutions to specific problems. However, it is often considered as a difficult area of mathematics. The difficulties associated with algebra are often credited to both its abstract nature and the difficult transition from arithmetic to algebra. Unfortunately, whilst many students struggle to grasp algebra, it is a very important area of mathematics, which has applications across other maths areas as well as other curriculum areas. Its focus upon the computation of unknown values through the use of symbolic representation is applied in almost all areas of mathematics, and therefore success in the math classroom relies upon a sound understanding of algebraic concepts. Proficiency in algebra is also considered to have great effect on competencies in many STEM subjects which employ algebraic skills. Linear relationships describe the relationship between a dependent and independent variable, which when represented graphically resembles a straight line. This relationship operates so that variations in the independent variable, commonly referred to as x, results in a corresponding variation in the dependent variable, commonly known as y. Knowledge of this linear relationship allows us to make predictions about the change in y according to a change in x. The common template for a linear relationship is y equals mx plus b. In this relationship, m is referred to as the coefficient or the multiplicative factor, and the b in this formula is represented by the constant. So in the Victorian curriculum, linear relationships first appear at level 7 under the linear and nonlinear relationships substrand, which is shown here. However, before this, students are developing their general algebraic skills and understandings under the substrands, patterns, and algebra, beginning from the foundation level. Okay, so learning trajectories are an important feature of the effective mathematics teaching. They highlight the hypothetical paths of learning which students may follow when exploring a new maths topic. They are beneficial for teachers as they allow teachers to identify at what point of learning trajectory the student is at the beginning of learning, and the relevant steps to help them continue to develop their conceptual knowledge and skills. They help teachers identify conceptual landmarks and obstacles students might meet when exploring maths content, and therefore help the teacher better prepare for possible misconceptions and difficulties that they may meet at each stage of development. Learning trajectories are built upon 3 components, including the learning objective, which explores the mathematical goal which the student intends to meet. Secondly is the learning activities, and finally the developmental path, which is a prediction of how the students will develop their thinking and understanding throughout the learning activities. So I developed my own mathematical goal using the VCAR level 7 content descriptor, which reads, given coordinates, plot points on the Cartesian plane and find coordinates for a given point. And the mathematical goal for this learning trajectory is I am able to graph simple linear relationships. Okay, and then the developmental path of this learning trajectory also drawed upon the VCAR mathematics curriculum, looking at levels 5 to 7, the numeracy progression standards presented by Akara, and also research, which was completed by Tua and Johnson in 2020. So just quickly looking through the developmental path, I began with looking at translate worded problems to number sentences. Then we moved on to using variables to represent unknowns. Next was balancing equations, then moving on to solve simple linear equations and plot simple linear relationships. And for each of these, I wrote up a description and a possible activity which could be used. Pedagogy is essentially describes a teacher's approach to teaching and learning. These pedagogies are often born from personal philosophies and values, influencing how curriculum content is expressed and delivered during the learning process. Inquiry-based learning is in the mathematics classroom involves students in an active learning experiences in which they construct their learning through a selection of carefully scaffolded sequence of mathematical tasks. Two features at the core of inquiry-based learning in the maths classroom are deep engagement in rich maths and opportunities to collaborate in some form. Deep engagement in rich mathematics classroom is characterized by engaging students in tasks which require them to grapple with mathematics ideas, face challenging problems, find appropriate methods to reach solutions, and then collaboration and inquiry-based learning may take the form of group work and discussing features of their work such as proof and conjectures. Collaboration allows students to practice expressing their work orally and written rather than simply symbolically. Okay, so one teaching strategy that I looked at for linear equations was the emergent models heuristic. So this strategy intends to assist students to initially develop an informal mathematical reasoning and then extend upon this to develop more formal and complex understanding. So this is completed by beginning with a problem which is situated in a very specific context, and then once completing this problem, generalizing this model and so that it can be applied to other situations. The next strategy which I explored was mathematical modeling. So this is considered to be a successful strategy as it gives students an opportunity to use their prior knowledge and to confront new conceptual needs. So this strategy requires the students to make take real life problems which they're familiar with and explore them using mathematical terms. Okay, so there are many reasons why learning in algebra is not equally accessible for all students in the classroom. Firstly, students with learning disabilities often have difficulty retaining facts. In the mathematics classroom, this can mean that they have difficulties remembering the facts which are needed to apply in algebraic situations. A common way to address these needs of these students is the use of repetition or rote learning. Whilst the use of this instructional approach does help students memorize algebraic rules and strategies, it fails to help students develop a greater understanding of complex concepts such as linear relationships. Students with poor reading comprehension skills have been shown to significantly underperform when faced with mathematical reasoning tasks when compared to their peers. A mathematical reasoning task is one that requires students to manipulate and analyze representations, diagrams, symbols, or statements to draw conclusions based on evidence or assumptions. Such tasks require students to demonstrate their thinking through the use of mathematical terms, everyday language, and the use of symbols. With the transition to middle school mathematics, students are required to develop these mathematical reasoning skills and approach more abstract maths concepts, meaning the importance of reading comprehension skills in the maths classroom becomes more significant. Pre-assessment is completed at the beginning of the exploration of a new topic. It is a form of diagnostic assessment, an assessment type which is considered as assessment for learning, giving teachers evidence of what stage of concept understanding students are located, whether there are common misconceptions being formed, and helping the teacher plan for future teaching. So a misconception must be clearly distinguished from a mistake. So a mistake is an error which can result from a simple mistake, such as completing your work too quickly and without proper care. A misconception is instead originates from a misunderstanding which the student upholds, which in turn leads to a systematic pattern of errors. One strategy which can be used to overcome misconceptions in the maths classroom is the use of analogies and anchors. This process includes finding and generating a situation to which the student will respond correctly, so that an anchor of mathematically correct knowledge is established. From this anchor or analogy, the teacher can then assist the student to begin the reconstruction process. The misconceptions which students commonly experience when facing learning in algebra have been identified by Tour and Johnson in 2020. In their research, they focus upon 3 common misconceptions, which are incorrect translation between worded problems and the formation of equations, misunderstanding the concept of equivalence, and finally confusing a letter that was representing variable as objects. To research these misconceptions and apply the anchoring strategy for reconstruction, Tour and Johnson developed 2 maths tests, version A containing questions of misconception-prone situations, whilst version B showed analogous questions designed with the aim of correcting those probabilistic and statistical misconceptions. So the reversal error describes the process of a student translating a worded problem into its algebraic equation form incorrectly. The student utilized the unknown variables, organizing them in a manner which results in an equation with a different mathematical meaning to the problem at hand. So one strategy to respond to this misconception is to substitute the variables for numbers and validate their answers. And so here shows 2 questions shown in version A and version B, which is using anchors to deal with this misconception. So next is the concept of equivalence. So when working with algebraic problems, many students misunderstand the role of the equal sign. These students view the equal sign in an operational sense, in which it denotes that one thing is equal to another, or that it symbolizes the announcement of the answer. Instead, the equal sign used in algebraic problems requires a relational approach, indicating a ratio. So here are 2 questions shown in version A and version B to explore this misconception, also using the anchoring process. Okay, and finally, we have letters as objects. So the final misconception stems from a common practice in which the translation of a worded problem to an algebraic equation uses the first letter of an object to represent unknowns. For example, using an A to represent the number of apples and a B to represent the number of bananas. Often, if these meanings are changed from the number of cost of to a weight of, etc., students will answer the question correctly, but misinterpret the meaning of the question. So here are two questions which were shown in the research, so version A and version B, to explore this misconception as well. Okay, thank you so much for listening. Here are all of the references which I had used. And I hope that you enjoyed.